Hello students, in this video we are going to solve the problems of exercise 5.1 of NCERT textbook of mathematics class 12. So in the last video we have already solved from question number 1 to question number 13, and in this video we are going to solve from question number 14 to question number 20, and link of the last video is provided in the description box. You may watch if you want. Now from question number 14 to 16, here we need to discuss the continuity of this function f, where f is defined. So in the question number 14, f is defined as f of x is equal to 3 when x is greater than equal to 0, less than equal to 1, then value of f of x is 3, and when x is greater than 1, less than 3, then f of x is equal to 4, and when x is greater than equal to 3, less than equal to 10, f of x is 5. So this is the given function. Okay, so let me write the solution here. Given function is this. So here clearly you can see the domain is, in this case domain is 0 to 10, close interval 0 to 10. Here is the domain 0 to 10. So now you can see the possible points of discontinuity are the points of partitions. What are the points of partitions here? 1 and 3. As you can see, 1 and 3. These are the points of partitions. So let me check its continuity at 1 first. So 1 and 3 are the points of discontinuity, possible points of discontinuity, as those are points of partitions. So at x is equal to 1, so f of 1, as you see in both cases, when x is less than or equal to 1, value of the function is 3. So that is why f of 1 must be equal to 3. Now let us find the left hand limit. Limit f of x tends to 1 negative. So for less than 1 also f of x is 3. So limit 3 x tends to 1 negative. So here it will be 3. Now let us find the right hand limit. Limit f of x tends to 1 positive. So that is going to be limit, and for x greater than 1, the function is 4. So value of the function is 4. So limit 4 x tends to 1 positive. So that is going to be equal to, yes, it is going to be equal to 4. So as you can see, left hand limit and right hand limit are not equal. So therefore you can write, since left hand limit is not equal to right hand limit at x is equal to 1, f is not continuous. F is not continuous at x is equal to 1, and here you see at x is equal to 3, at x is equal to 3, f of 3 is equal to here you see here if you see the third case here, for x greater than and equal to 3, in both cases the value of the function is 5. So therefore we have to write here 5, f of 3 is equal to 5. Now let us find the left hand limit f of x tends to 3 negative for left hand limit. So for less than 3, its value is 4 x less than 3. So f of x is 4, isn't it? So here we have written 4. So it is going to be equal to 4. Now right hand limit limit f of x x tends to 3 positive. For greater than 3, limit f of x is given by 5. So, here limit 5 x tends to 3 positive. So, it is going to be equal to 5. Here also left hand limit, right hand limit, both are not equal. So, since LHL is not equal to RHL at x is equal to 3, f is continuous, sorry, f is not continuous. At x is equal to 3. So, therefore, these two are the points of discontinuity. So, that means other than these 2 points, at all the points in its domain, it will be continuous. Therefore, you can write f is continuous at all the points in its domain. What was the domain? 0 to 10, close interval 0 to 10, other than the points 1 and 3. So, these 2 points should be excluded. So, that is how we can write. As you can see, function given in the question number 15 is f of x is twice x if x is less than 0. When x is greater than equal to 0 and less than equal to 1, f of x is given by 0, value of f of x is 0, and it is 4 x when x is greater than 1. So, I have not written the 1 here, there should be 1. Okay. So, here you can see clearly points of partitions are 0 and 1. So, let me check its continuity at 0 and 1 at x is equal to 0. So, f of 0, we know here at both the points, both cases at x greater than 0 and equal to 0, f of x is given by 0, that is why. So, f of 0 is 0. Now, limit left hand limit of f of x, x tends to 0, negative. So, for less than 0 we have this f of x is twice x. So, let us limit twice x, x tends to 0 negative, replace the x by 0, 2 into 0, that is going to be 0. So, right hand limit of f of x for greater than and equal to 0, both cases, f of x is given by 0. So, limit here it is 0 when x tends to 0 positive. So, it is obviously going to be equal to 0. So, here both left hand and right hand limit at x is equal to 0 is 0, both are equal to 1, f of 0. Limit left hand limit, right hand limit is equal to f of 0 at x is equal to 0. So, therefore, f is continuous, f is continuous at x is equal to 0. So, now let me check its continuity at x is equal to 1. At x is equal to 1, f of 1, we know for less than and equal to 1, the function f of x is equal to 0. So, that is why it is going to be 0, and left hand limit of the function f of x when x tends to 1 negative. So, for less than 1, in this case also f of x 0. So, it is going to be definitely 0, limit of 0 means 0. Now, right hand limit f of x, x tends to 1 positive. So, for greater than 1, here you see for x equal to x greater than 1, not equal to 1, greater than 1, the function f of x is given by 4 x. So, therefore, limit of 4 x, x tends to 1 positive is 4 into 1, that is going to be 4. So, here left hand limit and right hand limit are not equal. Since left hand limit is not equal to right hand limit is not equal to right hand limit at x is equal to 1, therefore, f is not continuous at x is equal to 1. Therefore, So x is equal to 1 is the only point of continuity, discontinuity, sorry. So f is continuous at all the points in its domain except x is equal to 1, except this point. Okay, hope you have understood. Now let's move on to next question. So here is the function in question number 16. If x is less than equal to minus 1, value of f of x is minus 2. When x is greater than minus 1 and less than equal to 1, then value of f of x is twice x, and it is 2 when x is greater than equal to 1. So this is the function. So let me solve this one. So here is the given function f of x. So here you see it is clear that here points of partitions are plus 1 and minus 1, these 2 points, minus 1 and plus 1, these 2 are the points of partition. So these are the only possible points where it may be discontinuous or continuous. It may be discontinuous. So may not be also discontinuous, it may not be discontinuous, it not necessary that it must be discontinuous. Let me check its continuity. Okay. So here you see at x is equal to minus 1, f of minus 1, as it is given here, you see for x less than and equal to minus 1, for x less than and equal to minus 1, f of x is minus 2. So that's why f of minus 1 is minus 2. Now let's find the left hand limit of f of x, x tends to minus 1 negative, that's going to be for less than 1 less than minus 1, f of x is minus 2. So here limit of minus 2, x tends to minus 1 negative, that's going to be minus 2. Now let's find the right hand limit of f of x, x tends to minus 1 positive here. So limit for greater than 1, for greater than minus 1, it is twice x, isn't it? F of x is twice x. So here it will be twice x, tends to minus 1 positive. So if you replace the x by minus 1, then you will get 2 into minus 1, that's going to be equal to minus 2. So here all these three values are equal at x is equal to minus 1. Therefore limit, left hand limit is equal to right hand limit is equal to f of minus 1 at x is equal to minus 1. Therefore f is continuous at x is equal to minus 1. Now let me check at x is equal to plus 1. At x is equal to plus 1. So when f of x is, here let me write f of 1. When you see when x is less than and equal to 1, when x is less than and equal to 1, then f of x is given by twice x. F of x is given by twice x. So therefore it's going to be 2 into x, means here x is 1, so 2 into 1, so that's going to be equal to 2. Now let's find a left hand limit f of x, x tends to 1 negative. For less than 1, again it is twice x, so limit of twice x, x tends to 1 negative, so it's going to be 2 into 1, that's going to be 2. Now let's find the right hand limit f of x, x tends to 1 positive, means right hand limit, or here for greater than 1, as you can see for x is greater than 1, f of x is 2, f of x, this function is 2. So that's why limit here only 2, x tends to 1 positive, that's going to be equal to 2. So here also you can see clearly left hand limit, right hand limit, both are equal. So that's why here you can write, since left hand limit is equal to right hand limit is equal to f of 1 at x is equal to 1, therefore f is continuous at x is equal to 1. So you can write, so only 1 and minus 1 are the points of discontinuity, possible points. They are, but here we have got these are not points of discontinuous here. So that means f is continuous at all the points in its domain. So let us solve question number 17. Here you see, find a relationship between a and b so that the function f defined by f of x, which is equal to ax plus 1 when x is less than equal to 3 and it is bx plus 3 when x is greater than 3, is continuous at x is equal to 3. That means this function f of x is continuous at x is equal to 3. So we need to find a relation between a and b for which this function f of x is continuous at x is equal to 3. So first let me write the given function here. Given function is given f of x is equal to ax plus 1 if x is less than equal to 3 and bx plus 3 if x is greater than 3. Let us find a left hand limit first at x is equal to 3. At x is equal to 3, at x is equal to 3, f of x is f is continuous, isn't it? So let us find the left hand limit. Limit f of x tends to 3 negative. So for less than 3, the function is ax plus 1. F of x is ax plus 1 for less than equal to 3. So that's why limit ax plus 1 x tends to 3 negative. So replace the x by 3 and doing so we will get thrice a plus 1. Then similarly find a right hand limit. So limit f of x tends to 3 positive and for greater than 3 f of x is given by bx plus 3. So limit bx plus 3 when x tends to 3 positive. So replace the x by 3, then you will get bx with thrice b plus 1. So here you see, as at x is equal to 3 f is continuous, therefore what, left hand limit must be equal to right hand limit. So let me write one thing here. Keep it only at this point, keep it x is equal to 3 only. So now write here, since f is continuous at x is equal to 3, therefore left hand limit and right hand limit must be equal at x is equal to 3. So here, so we got left hand limit here thrice a plus 1, this one, and right hand limit we have got thrice b plus 1, sorry, not plus 1, it's supposed to be 3, thrice b plus 3. So now thrice a plus 1 instead of plus 1, so b, transfer the 1 on the other side, and here you will get 3 minus 1. So thrice a is equal to thrice b plus 2. So this is the required relation. This is the required relation. Okay. Now let's move on to next question. So here is the question number 8. For what value of lambda is the function defined by f of x, which is equal to lambda into x square minus twice x when x is less than 0, and f of x is equal to 4x plus 1 when x is greater than 0, is continuous at x is equal to 0. First we need to find a value of lambda for which this given function is continuous at x is equal to 0, then we need to check the continuity at x is equal to 1. So first let me write the given function f of x. So let me drag it down. So here is the given function. So let me scroll up the page. Okay, so at x is equal to 0, let's find the left hand limit here. Left hand limit, so here it will be limit f of x, x tends to 0 negative. So that's going to be, here you see 4 less than 0, x less than 0, the function is given by this expression lambda into x square minus twice x. So limit of lambda into x square, sorry, lambda into x square minus twice x, x tends to 0 negative. So that's going to be equal to, now replace it by 0. So lambda into 0 square minus 2 into 0, that's going to be equal to lambda into 0, that means 0. Now let's find the right hand limit. Limit of f of x, x tends to 0 positive. So for greater than 0, for x greater than 0, f of x is 4x plus 1. So therefore limit 4x plus 1. So x tends to 0 positive, replace the x by 0. So it will be 4 into 0 plus 1, that's going to be equal to 1. Here you see left hand limit and right hand limit, these two are not equal, one is 0, another is 1. Since left hand limit is not equal to right hand limit at x is equal to 0, hence or therefore lambda does not exist. Exist at x is equal to 0. So hope you have understood this. For that means there is no such value of lambda for which the given function is continuous at x is equal to 0. So let me write the spelling correctly here, exist. Okay, so now we need to check the continuity of this function at x is equal to 1. So let me do it. So let me scroll up the page a little bit. So at x is equal to 1, so let's find the left hand limit at x is equal to 1. So here you see 1 is greater than 0. So doesn't matter which limit you find, left hand limit and right hand limit. If it is greater than 0 and for x greater than 0, it is always going to be 4x plus 1. Therefore left hand limit of f of x, x tends to 1 negative, that's going to be also limit 4x plus 1, x tends to 1 negative. If you find the right hand limit also, then also you need to write limit f of x, x tends to 1 positive. So limit of, here also we have to write 4x plus 1, so as x tends to 1 positive. So here you see this minus and plus sign on x tends to 1 positive or negative, this represents only left hand and right hand limit only. Okay, so when you put the value of x here, you don't have to write those negative and positive. Hope you have understood. Now let's evaluate, and it will be 4 into 1 plus 1, that's going to be 5. So here also 4 into 1 plus 1, that's going to be also 5. So therefore we can write, let me scroll up the page, therefore we can write f is continuous at x is equal to 1. Okay, now let us solve question number 19. Here, so that the function defined by g of x, which is equal to x minus greatest integer function of x, that means this term x within square bracket represents, it denotes the greatest integer less than or equal to x. So we have to show that here this function g of x, which is equal to x minus greatest integer function x, discontinuous at all integral points, at all integral points. So now let me show you your solution. Here g of x is defined as x minus this x within square bracket, x minus x within square bracket. So which is this part denotes the greatest integer less than or equal to x. That means suppose you see, suppose you have here 3 point something, then the greatest integer we can consider here 3 only, and if you have 2 point something, then we have to write here 2. If you have 2, then it will be 2. So I hope you have understood the meaning of this function. Okay. So that means this represents either less than or equal to x. So here you see this is the x and it is less than x, and here it is x, here it is equal to x. So if it is an integer, then it will be same as it is. If x is an integer, then greatest integer function of x will give x. If x is not integer, okay, then suppose you have x, suppose you have a number which is less than x, suppose less than x. Suppose you have a number y, suppose, which is less than x, but x minus y is less than 1. That means difference between these two is not more than 1. Okay, that means y point something is x. So in that case it will be equal to x minus 1. Suppose you have, as you can see, 2.9 is less than 3, and greatest integer function, if you take x is equal to 2.9, it will be given by 3 minus 1, isn't it? That is 2. Okay. So let us consider, let me clear this part. So now let us consider, let n be any integer, n be any integer, then what will happen? Then g of n minus greatest integer function of n will be n minus n is equal to 0, because we have considered n be any integer. If it is integer, then its greatest integer function of n will be also n. So hope you have understood, that is equal to 0. Now let us find the left hand limit. Suppose we have left hand limit, that is going to be limit of g of x, where x tends to n negative. That means it is not equal to n. So x approaching towards n, x is now less than n. In that case, what will happen? Limit x minus this x tends to n negative will be given by, if you replace the x by n, then here you will get n minus. Now as it is greatest integer function, now x is not exactly equal to n, okay, x is less than n. It is very close to n, but it is less than n. So as I have already given you an example, so 2.9 it is less than 3 and its greatest integer function gives 2, that is equal to 3 minus 1. So here also we will get, if x approaches to n from the left hand side, then mod of x for limit x tends to n negative must be given by n minus 1. So here it will be n minus 1. Okay. So now n minus n plus 1, that is going to be equal to 1. Here n cancel. Now let us find the right hand limit here. So, limit of g of x tends to n positive, that means x approaches towards x from the right hand side, that means this is x and on this side we have x values, this is suppose n, x approaches towards n from the right hand side. So, if this is n, then x is slightly greater than n. Okay. So, here you see, so limit of x minus square bracket of x, that is greatest integer function, x tends to n positive. Now, in this case, if you replace the x by n, here you will get my n. So, what will be the limit of this limit x tends to n positive of this one? What will be its value? Now, you see, when you have suppose a value 3.1 which is greater than 3, if you take the greatest integer function, if you evaluate it, then you will get 3. So, here this x is slightly greater than n, you can consider like that. Then in that case, this x is not, that means here x is less than n plus 1 and greater than n. So, in that case it will be n. So, hope you have understood. That is why so limit of this when x tends to n positive, limit of this greatest integer function will be given n. So, n minus n is equal to 0. As here you can see clearly that left hand limit and right hand limit are not equal, one is 1, another is 0. So, since LHL is not equal to RHL, so therefore, when we have considered this n is any integer, so we can say therefore or does just to mention one thing, and this left hand limit and right hand limit are not equal at x is equal to n, where n is any integer. Hence, g is not continuous. G is not continuous at all the integral points. So, that is how we can prove. So, hope you have understood. So, question number 20, here you see, is the function f of x which is equal to x square minus sin x plus 5 is continuous at pi. Is this continuous at pi or not? So, that has to be checked here. Now, here we will use this condition. Now, you see at a point x is equal to suppose c. So, a function is continuous when left hand limit is equal to right hand limit is equal to f of c. Or we can write the condition like this: if the limit exists, suppose this is a function f of x. So, at x is equal to c, suppose if this limit of f of x at x tends to c exists and it is equal to f of c, then also we can say it is continuous. Okay. So, here in this case we are not going to use this condition. All the problems we have done till now, we have used this condition, first one. So, here you see this limit to be exist, left hand and right hand limit both must be equal, we know that. But calculation of left hand and right hand limit in all the cases, sometimes it becomes complicated. That is why here we will use simply this. If the function is defined like this, suppose f of x is equal to suppose x, if x is greater than something or less than something, it is x square if x is less than equal to something, suppose. In that case it is easier to find left hand and right hand limit. Okay. So here also we can find, but it will be easier if we use the second condition, this one. So if we use the second condition, so let me use this condition. So here first we are going to find the limit. So first write the given function, that is f of x is equal to x square sin x plus 5. So at x is equal to pi, first find f of pi. So that's going to be equal to pi square minus sin x, instead of x there will be pi plus 5. So what is the value of sin pi? So we can consider this one as sin pi plus 0, sin pi plus 0 plus 5. So if you apply ASTC rule, this is pi, here up to this pi plus something is in the third quadrant. So that's why pi is even multiple of 90, so sin remains sin, but at the third quadrant it will be negative. So negative it will be positive, sin 0, we have got here sin 0 plus 5. So sin 0 is 0, so pi square plus 5 we will get here. So this is the f of pi. Now let's find the limit of this function. Okay, limit of this function. So limit of f of x as x tends to pi, so that's going to be equal to limit x square minus sin x plus 5. So x tends to pi. So if you replace the x by pi, then again you will get pi square minus sin pi plus 5, which is again it will be equal to x square pi square plus 5. So these two equal. So that's why since you can write limit f of x as x tends to pi is equal to f of pi, hence f is continuous at x is equal to pi. So hope you have understood this. So let me write the spelling properly. Continuous. So that's how we can solve question number 20, and I will show the remaining questions in the next video. So from question number 21 to question number 32. Please subscribe my channel Maths Tutor Lekkhajit and inspire me to create new contents for you. Thank you for watching.